All right, welcome back to the deep dive. Today we're taking a look at something that probably impacts you every day.
Yeah, we're going to be talking about recommender systems.
Exactly, recommender systems. So, these are those algorithms that are like constantly suggesting things to you, whether it's on like your favorite streaming service or, when you're shopping online. And, we're going to specifically be talking about the next generation of recommender systems, which is like really exciting. We're going to be looking at how large language models, those LLMs everybody is talking about, are starting to step into this really cool role of being these like intelligent and interactive recommendation assistants.
Right. They're getting a lot more sophisticated. For a while, these systems were kind of basic, right? Like, if you like this, you might like that. But things are a lot more complex than that now, right?
Yeah.
Like, think about it. When you are looking for a movie, you might have specific actors in mind. Or you might be, looking for something with a specific theme, or even if you're shopping, you might want very particular features.
Exactly. Yeah. Like, I need a laptop, but it needs to be this size and have this much memory and under this price.
Right, exactly. And those are the kinds of nuanced requests that traditional systems really struggle with. But that's where LLMs are coming in, because they have this potential to really understand and respond to your needs and even have a conversation with you about it.
Yeah. So instead of it being like you just click on something and then it's like, oh, you clicked on this, so here's a bunch more just like that. It can be more like, I'm looking for something that's kind of like this, but also like this. And it can kind of understand those more nuanced needs.
Absolutely. And that makes the whole experience a lot more personalized.
Exactly. Yeah, it really does. But there is a catch, right? Because this new paper we're diving into points out that even though LLMs are showing all this potential, the ways that we are evaluating them right now for these recommendation tasks, they're not really keeping up.
Right. The evaluation methods are still pretty basic, and they don't really reflect how complex real-world interactions actually are.
Yeah, because in the real world, you don't just like walk up to a person and be like, give me recommendations.
Exactly.
There's a whole conversation that leads into it.
Right.
And so how do we know if these LLM powered assistants like are actually understanding and fulfilling those more involved needs if we're not testing them in the right way?
That's a great point. And that's really the gap that this paper and their new benchmark are trying to fill. They've created RecBench plus AL, and it's specifically designed to be kind of a more testing ground, to really push these models to their limits and see if they can handle the complexity of how we actually ask for recommendations.
Okay, I like that. RecBench plus pushing them to the limit. So let's talk about this paper. What made them want to create this new benchmark in the first place?
Well, they start off by just emphasizing how ubiquitous recommender systems are. I mean, they're everywhere, and we rely on them so heavily in our digital lives. But traditional approaches have really focused on those, simpler scenarios. And with the rise of LLMs, they're saying, hey, we could do so much more now.
Right. Yeah.
We can create way more sophisticated assistants. So they wanted to come up with a way to evaluate whether these LLMs can actually understand and respond to the kinds of complex queries that a user might actually have.
So it's like, we've got these powerful new tools. Now we need a way to measure how powerful they really are.
That's a great way to put it. Yeah.
And what are like the main weaknesses of those older methods? Like, what is RecBench Plus really trying to fix?
So the paper argues that a lot of the current evaluation methods depend on these like fixed, very task-specific prompts. And the problem with that is they don't really capture how dynamic and multifaceted real-world interactions are.
Right. Yeah.
I mean, when you ask for a recommendation, it's hardly ever just this straightforward single attribute request.
Like, you're never just like, give me a movie with Tom Hanks and that's it.
Right, exactly. You might have multiple conditions, or maybe you have some preferences that are only implied, not explicitly stated, or you might even have some incorrect information in your query.
And the older benchmarks just don't really account for that.
Exactly.
It's not a very realistic test.
So we haven't had a good way to really measure how well these LLM assistants are performing in more realistic conversational settings. And that's what RecBench Plus is all about.
Okay, so tell me more about RecBench Plus. Like, what is in this new data set?
So they've got about 30,000 high-quality user queries, and they're all complex. And it's built on some, really well-established data sets that are already out there, like MovieLens 1M for movies and Amazon book reviews. But they've added this extra layer of complexity. And they've categorized these queries into two main types.
Okay.
Condition-based queries and user profile-based queries.
Okay, so let's take those one at a time. First, what are the condition-based queries?
So condition-based queries are like those situations where you have a pretty good idea of what you want, and you can express it with like specific limitations.
Okay.
So, you're putting some conditions on it,
Okay.
and they actually divide this category into 3 more subtypes.
Ooh, okay. Tell me about those.
So first you've got the explicit condition queries, and these are like the most straightforward ones. You just state your requirements directly.
Okay.
So like movies featuring Gwyneth Paltrow.
Oh, okay.
That's it. Nice and simple. And the system's job is to accurately filter and recommend things that match those conditions.
Straightforward. Okay.
Now, the next level of complexity are the implicit condition queries. And these are trickier because you're only giving partial information.
Ah, okay.
And the system has to infer those underlying conditions.
Okay.
So a good example is, can you suggest movies with the same cinematographer as Stay Hungry and Beethoven?
Mm-hmm.
Now, you don't actually say who that cinematographer is.
Right.
So the system has to figure that out on its own. It has to reason, go into its knowledge base, identify the cinematographer, and then recommend movies based on that.
So this is less about like just word matching and more about like actual understanding and knowledge.
Exactly. Yeah. It's a whole different level of how we expect these systems to function.
Yeah, I like that. Okay, so we've got explicit, we've got implicit. What is the third type of condition-based query?
So the third type is misinformed condition queries.
Yeah.
And these are like really interesting because they're designed to see how robust the assistant is. So what you do is you give it incorrect information, like Avatar, directed by Spielberg.
Okay. Yeah.
And ideally, a good system should be able to flag that error and still give you relevant recommendations.
Yeah, or be like, hold on, are you sure about that?
Right. Exactly. Like maybe focus on the fact that you're looking for like a visually stunning science fiction film. Kind of like working around that misinformation.
Yeah, be helpful instead of just like, breaking.
Right, exactly.
Okay, I like that a lot. So that's our condition-based queries. Now let's move on to user profile-based queries. What are those about?
Okay, so user profile-based queries are all about personalization.
Okay.
Understanding you as the user. And this category also has 2 subtypes. The first is interest-based queries. So these aim to like capture your preferences that you don't necessarily define by specific attributes.
Okay.
So like, let's say you watch a lot of movies with, unique storytelling and they're visually beautiful, like The Tree of Life or 2046.
Okay.
An interest-based query might be something like, hey, I just watched The Tree of Life and I loved how poetic and visually stunning it was. Can you recommend other movies with a similar tone?
Okay.
So there aren't any like explicit conditions there, but the assistant needs to understand that implied interest.
So it's not just what you've watched, it's why you watched it.
Exactly.
Okay, I like that. And then what is the second subtype of user profile-based queries?
That would be demographics-based queries. And these explore how things like your age, gender, or even your job might influence your preferences. So for instance, I'm a philosophy professor and I'm looking for movies with complex themes and moral dilemmas.
Okay.
Stuff like that.
Okay.
That's testing if the assistant can leverage like those broader demographic trends to recommend things.
That makes sense. Okay, so we've got this RecBench Plus data set, and it sounds incredibly comprehensive in how it is mimicking real-world interactions. So how did they actually build it? Like, how did they create all of these queries?
So for the condition-based queries, they actually got really clever, and they used knowledge graphs.
Okay.
Specifically Wikipedia for movies and the Amazon book dataset metadata.
Okay.
And the idea was to take the structured information from these knowledge graphs and extract those shared relations from user history. So like if you watched a bunch of Christopher Nolan films,
Okay.
then directed by Christopher Nolan becomes a shared relation.
Okay, so they're looking for those common threads.
Right. And then, based on these shared relations, they went ahead and created those 3 types of condition-based queries that we talked about. So for the explicit queries, they pretty much used those relations directly as the condition. But for the implicit queries, they did something more interesting. Instead of saying like the director's name directly, they used the knowledge graph to describe it indirectly.
Okay.
So instead of movies by Christopher Nolan, it might become movies by the director of Inception.
Right, yeah, so it's not as straightforward.
Exactly. Yeah.
Okay, so how about the misinformed queries? How did they make those?
So for those, they basically introduced errors, on purpose.
Oh, okay.
So for a particular relation, they might pick something from the knowledge graph that doesn't actually have that relationship.
Okay.
So like instead of movies starring Leonardo DiCaprio, they might say, movie starring Leonardo DiCaprio in Titanic, directed by Spielberg.
Okay.
Because Spielberg didn't direct Titanic, right?
Right.
So that's a good way to see if the system can actually cross-reference and, point out these inconsistencies.
Yeah, it's a good test. Okay, and what about those user profile-based queries? How did they build those?
So for interest-based queries, they looked for what they called common interest sets.
Okay.
And those are items that a lot of users interact with, like back to back.
Okay.
One after another.
Okay.
And they also looked at what they called preceding item sequences, which are like, what did people watch before they got to those common interest sets?
Okay.
The idea is that these patterns can reveal some underlying interests.
Okay.
So they used LLMs to analyze these patterns and then generate natural language queries that reflect those inferred interests.
Okay, so using the collective behavior to understand the individual interests.
Exactly.
Okay.
And then for the demographics-based queries, they grouped users, by shared attributes like age, gender, occupation.
Okay.
And within those groups, they looked at the items that were consumed the most, the most popular ones.
Okay.
And then they used LLMs to take that demographic information and that list of popular items and then generate a query that reflects the preferences of that specific demographic.
Okay. It sounds like a really well thought out process.
Yeah, they were very thorough in how they put this benchmark together.
Okay, so once they had this RecBench plus Miro, how did they actually evaluate the performance of all the different LLMs that are out there?
Okay, so they chose some really widely used ones,
Okay.
including GPT-4o, Gemini, DeepSeek, Llama, and Claude.
Okay.
They kind of put them through their paces,
Okay.
and they didn't specify how many recommendations they wanted the models to generate because, that's not how it works in the real world.
Right.
And they used a few metrics to look at the performance.
Okay, so how do you measure how good an LLM is at giving recommendations, especially in these really complex scenarios?
Right. So they use some standard metrics like precision and recall,
Okay.
which basically tell you how relevant and complete the recommendations are. But they also introduced a new metric called condition match rate,
Okay.
or CMR. And this one looks specifically at the percentage of the recommended items that actually stick to the conditions in the query,
Okay.
which is really important for those condition-based queries, right?
Yeah.
So it's not enough to just recommend good stuff. It has to fit the specific request.
Right, exactly.
They also looked at the fail to recommend rate,
Okay.
or FTR, which is how often the model couldn't come up with any recommendations at all.
Okay.
And this is interesting because with those misinformed queries, a higher FTR could actually be a good thing.
Yeah, because it means it's recognizing that there's something wrong.
Exactly. It's realizing it's working with bad info and it's choosing not to give a recommendation, which is actually smart.
Right. So what did they find after they did all of these evaluations? What were some of the key things they learned?
So a few things really stood out. First of all, LLMs like GPT-4o and DeepSeek R1 did really well overall as these recommendation assistants. Particularly DeepSeek R1 was amazing at those implicit condition queries.
Okay.
The ones where you don't give all the info.
Yeah.
Which suggests that it has some pretty good reasoning abilities.
Yeah, because those are the ones where you really have to think to figure out what the user actually wants.
Exactly. And another key finding was that as the queries got harder, the performance went down.
Okay.
So explicit conditions were the easiest,
Okay.
then implicit, and then misinformed was the hardest.
Okay, so it makes sense. As you add more complexity, it becomes more difficult.
Right.
That makes sense.
But it's good to, actually quantify those challenges.
Right.
They also saw that adding more conditions to a query could make the precision and recall better
Okay.
because you were narrowing down the scope of the recommendation.
Right. Yeah, that makes sense.
But it affects the condition match rate differently depending on the type of query. So basically, more specific requests might give you more relevant results,
Okay.
but it also might be harder to satisfy all those constraints at the same time.
Right. Yeah, you're giving it more things it has to get right.
Exactly. They also looked at what happens when you add the user's past interactions into the mix.
Okay.
And they found that, in general, it improved personalization, and that led to better precision.
Okay.
But sometimes it negatively impacted the CMR, meaning the recommendations weren't adhering to those conditions as strictly.
Okay.
So it seems like the models might be prioritizing things similar to what the user have done in the past, even if it doesn't perfectly match what they explicitly asked for.
Right. So it's like a trade-off between giving you what you said you want and giving you something that it thinks you might like based on your past behavior.
Exactly. And that's a really important consideration when you're designing these systems.
Yeah, it's a balancing act. Okay, what other findings did they have?
For the user profile-based queries, Gemini 1.5 Pro and DeepSeek R1 did really well again.
Okay.
And they found that demographics-based queries had lower recall than interest-based queries, which implies that it's harder for these LLMs to just use demographics to infer preferences.
Okay.
And something kind of interesting they found was that for interest-based queries, if the query was based on a less common interest,
Okay.
it was actually harder for the LLMs.
Okay.
But there was an opposite trend for book recommendations, which might be because of how book data is organized, with all the editions and publishers.
Oh, okay. So like the structure of the data can actually impact the results.
Exactly, yeah. And one last thing, the performance on the demographics-based queries actually varied depending on the specific demographics.
Okay.
So there was higher recall for women and people between 50 and 55, which suggests that maybe there are more consistent preferences within those groups.
Okay, so like more predictability. Interesting.
Yeah, it was interesting.
So overall, it sounds like these LLMs are showing a lot of promise as recommendation assistants, but there are definitely still areas where they need to improve, especially in complex reasoning, dealing with misinformation, and understanding user profiles on a deeper level.
Absolutely, yeah. And the study really emphasized how important it is to use external knowledge, like those knowledge graphs, and user history to make them better.
Yeah. So this paper really presents RecBench Plus as like a critical tool for pushing the field forward.
Absolutely, like essential.
But to really understand where this fits into the bigger picture, I think it's helpful to take a step back and look at like how we even got here. Like how did we get to the point where we're even considering LLMs for this task?
Yeah, good point. So recommender systems have been a big area of research for like decades. It started with these basic collaborative filtering methods like matrix factorization, which basically try to find patterns in how users rate different items.
Okay.
And those methods worked okay for, simpler recommendations.
Okay.
But as deep learning started getting popular, researchers started applying that to recommender systems, which led to techniques like neural collaborative filtering, where neural networks were used to learn more complex representations of users and items.
Okay.
And that could handle, bigger and more complex data sets.
Okay.
And then graph neural networks came along, which represent the relationships between users and items as like a network, so it could leverage those connections.
Okay.
And each of these advances, they significantly improved the accuracy and the ability to handle all this data.
But it was still mostly implicit, right? Like based on your past actions, not your words.
Yeah, exactly. You're just clicking on things, not having a dialogue about it.
Right, exactly.
But then LLMs came along, and that was a huge shift.
Yeah.
Because they can understand and generate natural language.
Okay.
So they have the potential to make the whole recommendation process much more interactive.
Okay.
Like instead of just clicking or rating stuff, you can just say what you need.
Right.
So RecBench is really a direct response to that evolution because the old ways of evaluating these systems just aren't cutting it anymore.
It's like we've upgraded our tools and now we need to upgrade our testing methods to match.
Precisely.
So for our listeners, people who are into machine learning research, what are the really key takeaways from this paper?
Okay, so the biggest contribution is definitely RecBench plus BESS itself. It's a brand new benchmark that is built to evaluate these LLM-based recommendation assistants when they are faced with like real-world complex queries.
Right.
And that addresses the shortcomings of the old benchmarks that couldn't assess things like understanding and reasoning.
Yeah.
Also, the paper gives us a really comprehensive analysis of how several different LLMs do on this new benchmark.
Okay.
So you can see their strengths and weaknesses, and it highlights those areas where we need more research.
Right.
Like handling those implicit or misinformed conditions, or really understanding what users prefer based on their demographics.
Okay.
And third, the way they built RecBench plus BESS, using those knowledge graphs and the user interaction data, that gives us valuable insights into how to create more realistic and challenging evaluation data sets in the future.
Yeah, so we can keep making better and better recommender systems.
Right. And, the paper is saying that it's not enough to just use those simple metrics.
Right.
We need more nuanced approaches that can really show us what LLMs are capable of and also where they are limited.
Absolutely. This is all really important stuff for anyone in machine learning, particularly if you're working on NLP or recommender systems. Now it's time for our novel notions segment.
Oh, yeah.
So based on this paper and what's happening in machine learning right now, what are some really interesting, maybe even a little bit futuristic research ideas that come to mind?
Okay, so my first research idea is inspired by those challenges that RecBench Plus highlighted.
Okay.
You know, how even those super advanced LLMs struggled with certain queries.
Yeah.
So I think it would be really cool to explore ways to fine-tune them,
Right.
specifically for recommendation tasks.
Okay, so like specialized training to make them better at giving recommendations.
Exactly. Like, what if we could develop techniques to make them better at reasoning when there's implicit or misinformed conditions?
Okay.
Or, help them understand user interests without relying so much on just demographics.
Okay.
And we could even use things like reinforcement learning with human feedback, where the feedback is specifically about recommendations, or maybe curriculum learning, where we gradually give the LLM harder and harder queries from RecBench Plus.
Okay.
And I think this could lead to specialized recommendation LLMs.
Okay.
Ones that are like way better than the general purpose LLMs when it comes to these benchmarks.
Like fine-tuned for a specific purpose.
Exactly. I think that would be really exciting to explore.
I like that a lot.
Right.
Okay, what about your second novel notion?
So my second idea is about building hybrid recommendation systems.
Right.
Where you combine LLMs with those more traditional models. Because LLMs are great at understanding those complex natural language queries. And they're good at reasoning, but they might not be the best at like directly going through these huge real-time item catalogs.
Oh.
Or learning from all that historical interaction data.
Right, yeah.
That's where those traditional models shine. So what if we created a system where the LLM is used to understand the request and get those high-level preferences and constraints?
Okay.
And then we feed that into a more traditional model that's really good at searching and ranking.
Okay.
And then the LLM could like polish the results or even explain those recommendations in natural language.
Okay.
And that way we could overcome some of those limitations of using LLMs alone and make those systems even more robust and scalable.
Yeah, so basically using the strengths of both approaches to create something even better.
Exactly.
Those are some really interesting ideas.
Yeah.
And it shows how this paper is doing more than just providing a benchmark. It's also sparking all these new ideas and moving the whole field forward.
Yeah, absolutely.
But of course, as always, we want to remind our listeners that these novel notions are just, speculative research ideas. This is just us brainstorming.
Yeah. Just fun thought experiments.
Right. But the goal is to get people thinking, and to encourage innovation in this really rapidly evolving area.
Absolutely. The more ideas we can generate, the better.
Okay, so to wrap up our deep dive into this RecBench Plus paper, I think the key takeaway is that large language models have the potential to completely transform recommender systems.
Yeah, they really do.
This benchmark gives us a critical tool to measure our progress.
Absolutely.
And to figure out what challenges we still need to tackle,
Right.
As we're building these truly intelligent and interactive recommendation assistants.
And it really pushes us to think carefully about how we evaluate these systems.
Yeah.
And to focus our future research on overcoming those limitations so we can create better, more personalized recommendation experiences for everyone.
Yeah, because everybody loves a good recommendation.
Absolutely. Especially if it's something you didn't even know you were looking for.
Yeah, that's the best. Okay, so for those of you who want to dive into the details of this paper, we've included a link in the description. And be sure to join us next time for another deep dive into the world of cutting-edge machine learning research. Thanks for listening.
See you next time.